Today we're going to continue talking about proportional relationships. We talked a little bit about unit rate last week. We'll talk more about that, and we're also going to talk about equations for proportional relationships. So let's jump into this. Robert's new hybrid car has a gas tank that holds 12 gallons of gas. When the tank is full, he can drive 420 miles. Assume his car uses gas at a steady rate. So first question, is the relationship between the number of gallons of gas used and the number of miles that can be driven proportional? What do you guys think?
I think it's correct.
Hopefully all of you have answered this at this point, so everyone has an opinion. So by a show of hands, how many of you think it is proportional? All right, everybody thinks it's proportional. It's just that no one said anything. So, yes. Now let's explain how we know. Well, if he had 0 gallons, he could drive 0 miles. Part of what's important is that it's going to go through 0, 0. And the other part that's important is that if he had half as much gas, would he be able to go half as many miles? Yeah. If he had half as many miles, he could only go half as far. And we can show that here on this table. If he had 12 gallons, he went 420 miles. 6 gallons then would be 210 miles. How much would 3 gallons be? Anyone? 105. And 0 would be 0. So Robert decided to graph the situation as shown at the right. The distance Robert can travel using 1 gallon of gas is called the unit rate. Use Robert's graph to predict how far he can drive using 1 gallon of gas. That is, estimate his unit rate. And they do just want you to estimate it right now. So if we're at 1, what does that look like it's about?
30.
Looks like it's about 30. And that would be 30 miles per gallon. So from the graph, it looks like it's about 30. Turns out it's not exactly 30. Let's use this table. He could drive 105 miles if he had 3 gallons. And if I do that as miles per gallon, that's 105 miles per every 3 gallons, right? That's how I know that this is a unit rate, because it's miles per gallon. And then we'll reduce that. 3 goes into 105. 35 times? So 35 miles per gallon. So we were close when we estimated that it was 30. But that's one of the problems with a graph sometimes, is it's difficult to get exact answers. So the equation to find the exact number of miles Robert can drive with any number of gallons, because this is an algebra class, algebra classes tend to do everything in X and Y's. I'm not, strictly speaking, an algebra guy. I'm more geometry, calculus, statistics. I use representative variables. Using X and Y for everything doesn't make any sense to me. So what I would do is do M is equal to 35 G, where M is equal to the number of miles Robert can drive, and G is equal to the number of gallons of gas Robert has. By the way, if you do it in X and Y, you still need to define your variables. You can't just write an equation and assume people know which a variable is which. Yes, sir. You had a question? No? Okay. All right, so let's use our equation to find out how many gallons of gas Robert will need to drive 287 miles. Okay, so if it's 287 miles, is 35 times the number of gallons. What do we need to do to solve that? What should we do, Warren?
Division.
Yeah, we're going to divide. How many times does 35 go into 287? It's not going to go evenly, that's for certain. Let's see, 70, 140, so is that 8? And we'll go ahead and add on a decimal and bring down the 0. 35 goes into 70 twice. So that would be 8.2 is the number of gallons. Yes, ma'am.
Where did we get the 287 again?
I was given in the problem.
Oh, yeah, sorry.
All right, let's go on to page 2. So, Lexi claims that she can send 14 text messages in 22 minutes. Her parents must be so proud. Her teammates, Kenny and Esther, are trying to predict how many text messages Lexi can send in a 55-minute lunch period if she keeps going at the same rate. So, is the relationship between the number of text messages and the time in minutes proportional? Yeah. So what are two things we need to consider? Well, consider 0. If she has 0 minutes, how many text messages can she send? 0. So with 0 minutes, she can send 0 text messages. And let's do with half as many again. You can do half, you can do double, you can do triple. thing that you're multiplying by the same number each time with half as much time, she would only be able to send half as many messages. All right, so Kenny represented the situation using the table shown at the right. So with 14 messages in 22 minutes, 7 messages in 11, what could we do to figure out how many she can send in 55? Yes, sir.
7 times 5.
Yeah, because we have quintupled the number of minutes, multiplied it by 5. So let's multiply this by 5 also, and it would be 35 messages in 55 minutes. Very good. So Esther wants to solve the problem using an equation. So let's help her to write an equation to determine how many text messages Lexi could write or send in any number of minutes. And that should be not but by first finding the unit rate. So let's do this in messages per minute. It was 7 messages in 11 minutes, right? Can we do anything else with that? Can we simplify that anymore? No. So 11 messages in 7 minutes means that she can send 11/7 of a message per minute. Sometimes that doesn't come out to be a whole number, and that's okay. We won't ever take the time to change that into a mixed number either. There's not really any good reason for it. It's a little over 1.5 messages per minute. So the number of texts is going to be equal to 11/7 times the number of minutes, where T is the number of texts and M is the number of minutes. So let's use Esther's equation. Yes, sir.
7 is the messages.
Oh, I'm sorry. Thank you. I did that upside down. So it's 7/11. So then to find out how many text messages she can send, we'll do the number of texts is 7/11 times 55. Remember that 55 is over 1. 11 goes into 55 5 times. And 5 times 7 is 35. And yes, it matches up with what we had in the table. Had Warren not corrected me, we would have gotten something different. And that's when you know something's gone wrong. All right, let's move on to some other examples. Graham earns $4.23 for each half hour that he works. How much money does he earn during a given amount of time? So let's use this table. We need to label them. So money earned in dollars, and then the time in hours. So it's $4.23 for half an hour. So how much is it for 1 hour? Yes, sir. Exactly right. $8.46. If he was to work 2 hours, then what can we do to find that? Yes, ma'am.
$8.46 times 2.
Yeah. That would be what, $16.92? If he was to work 3 hours, there's a couple of ways we could find that. What's one way we could find the 3 hours? Yes, Quentin?
16.92 plus 8.46.
Yeah, we could just add the 1 and the 2. So that's 24, 25 something. $38. Yeah, I believe that's correct. Y'all double check my arithmetic. And then if we were going to do 4 hours, what would be the simplest way to find that one? Yes, sir.
16.92 plus 16.92.
Yeah, or multiply it times 2, either way. So it's 3384. So what's the constant of proportionality or the unit rate? Yes, sir.
It's 8.46 per hour.
What's per hour?
$8.46 earned per hour.
Yeah. $8.46 per hour. How can you find it in the table? Well, you just look for where the dollar or the time is 1. So find the dollars when time is 1. And then from the table, how can we tell that this is a proportional relationship? Yes?
It goes through the origin because
We don't see that on the table, so we can't say that.
oh,
It
well,
does, but we don't see that on the table.
I guess you could if you worked on it earlier, but 2 is half of 4.
Okay,
It's a line.
so what doubles?
The money earned doubles per time.
When the time,
When the time doubles, the money doubles.
there we go. When the time doubles, the money earned doubled. And that's something that I'm going to do on a quiz or on a test. I'll give you a table that'll already be filled out. And with a table, the easiest way to look is if one of them doubled, did the other one double? Or if one of them tripled, did the other one triple? It doesn't matter what you're multiplying by, as long as they both multiply by the same amount. All right, let's go on to page 3. All right, so Jamie ran 9.3 miles in 1.5 hours. How far can she run in a given amount of time if she runs at a constant rate? Well, let's take a look here. If she ran 9.3 miles in 1.5 hours, you may have never had to reduce a fraction like that, where they're both decimals. It's not difficult though. I'm just going to multiply top and bottom by 10 so that I can get rid of the decimal. So that'd be 93 miles in every 15 hours. And that is somewhat reducible, at least. What are both of those evenly divisible by? 3. So it'd be 31 miles in every 5 hours. So let's graph this. Bless you. So this is going to be time in hours. And this will be distance in miles. So I'm going to do the hours by ones, but I'm not going to mark every single one of them. We talked about that last week. I'm only going to go to 15 hours because that gives me nice whole numbers, right? I need to go up to 93. So what do you think? If we go by 5s on these, will this be enough? If every one of them is 5, I think that will be. That would be 10, 20, etc. So we figured out that at 15 hours, it would be 93. So about there. We also figured out that at 31 miles for 5 hours, so 5 hours, 31, right about there. And if she ran for 0 hours, how far will she have gone? 0. And then we can connect those. Looks pretty straight to me. So the constant of proportionality for this is 31/5, which would be 6 1/5. Where can we find it on the graph? Well, it's right here when the time was equal to 1. So 6 1/5 or 6.2 if you prefer the decimal, either one of them is fine. Is that very easy to see exactly with the graph? No, with the graph, it's especially difficult. I would have thought it was probably more than that. So how can we use a graph to determine if a relationship is proportional? Got to look for two things. What's one thing? Pardon? It's got to go through the origin. And what's the second part? I heard. No, just from just looking at the graph.
A line.
It's a line. It's got to be straight. If it's not straight, it's not a proportional relationship. So from a table, the easiest thing to look at is if one quantity doubles, the other quantity has to double. From a graph, you got to go through the origin, and it has to be a line.